OpsSQL is an excellent tool to look at your correlations between data sets. Many times our customers need to look at online instrumentation data versus the laboratory data to see that those things are keeping in sync, that nothing needs to be calibrated or to detect when calibrations need to be done, and to build models of their plan. In this case, I'm going to take you through an example of comparing my Influent BOD, which is a 24-hour composite test that goes to the lab, versus my HQ440D data, which is an online instrument that hooks into my SCADA system. Now, the UVOS reading represents a UV absorption reading of the organic material in your influence stream. So it's a very good correlation to the BOD. It should be a little bit higher because it represents the total organic. And in this case, the customer wants to kind of prove that they do correlate, so we can use this to not wait 5 days for my BOD test to be done, that I can start to operate the plant based on this UVOS meter. So again, I've already got the data in the system. Ops is a great place to pull all that data together. You set it up. The BOD is already in there because we need it for our regulatory reporting. UVOS is getting into the SCADA system. So I'm just going to hook that point up into an ops variable and basically say I want to get the daily average to compare it to my 24-hour composite values that I'm getting from my BOD. So in this case, to do that comparison, I'm just going to come in here and say I want to graph those two data points over time. So I come in here and I do BOD versus my UVOS. And I click view and I see that the UVOS is a little bit higher in general, but they correlate very well, that they keep this kind of simple gap in between them. And again, with the graph pack, I can look back over the history of time. Some of these points, again, the BOD data is coming from the lab. The red line, the UVOS reading, is coming from my SCADA system, but I can easily put these on the same graph, and I have some shortcuts that make it easier if I want to look at longer data periods. Notice that my UVOS reading has got 5 more data points on it. That's because, again, the BOD is a 5-day test, and this is up to the current date, so I can't know this data till then. So it looks like I got a pretty good correlation. So now let's figure out how to represent that mathematically. And what we have is correlation plot. So what we want to do is we want to look at our UVOS versus our BOD. And I'm going to go ahead and view this data. And again, what it's going to do is it's going to just do a scatter plot. So again, if I was to read this graph when my UVOS is 250, my BOD is about 225 or something like that. So it basically draws a best fit line through the data and allows you to prove mathematically. What's nice is it will actually show you the equation of the line and the coefficient of correlation. And a 0.95 is a very good correlation, so I can feel very, very confident about this number that it's generating. I can further take this example further now and copy this out and make a calculated variable in our system. So on a day where I know my variable 21 here, my UVOS reading, it will calculate my predicted BOD. So I can use that so that people can kind of see the data in the BOD units. It makes them feel a little bit better. So doing a pretty complex study of data is trivial in ops because all the data is already there. I just plot it in the graph, generate my equations, generate my coefficients of correlations, and I don't have to be a statistician to do this stuff. Just kind of fill out the form and I'm off.